Observe as Specimen A eats his nutritious lunch. The food that he consumes is chock full of sugar. But what exactly is going on inside his body? Well, right now this sugar is being converted into glucose in his digestive system, which will be turned into energy via cellular respiration. Pay attention now. We're about to begin. The first step of cellular respiration is glycolysis. Glycolysis is the step in which glucose is broken in half. It takes place in the cytosol of a cell. Note here that the magician represents several different enzymes. 2 ATP molecules are added, providing the energy for various enzymes to break the glucose molecule in half. Two carrier molecules called NAD come in and remove electrons. In doing so, they are reduced, as reduction is the gain of electrons. These NAD molecules will be used later. Numerous chemical reactions are taking place, but finally, 4 ATP are made, and the glucose has successfully been converted into 2 pyruvates, which are 3 carbon molecules. This pyruvate molecule is now entering the mitochondrion stroma, where the Krebs cycle, also called the citric acid cycle, will begin. The Krebs cycle is a series of chemical reactions that harvest electrons from high-energy molecules derived from pyruvate through several sequential steps. Coenzyme A is important to remember too, as it allows pyruvate to enter the Krebs cycle in the first place. The actual Krebs cycle is much more intricate and lengthy. Shown here are some of the most important steps in the cycle. Note that the chef represents various enzymes. The hydrogens that the carrier molecules pick up are from the intermediates of the Krebs cycle. Keep in mind that for every 1 glucose molecule, there are 2 pyruvates which must each pass through the Krebs cycle. FAD is another electron carrier molecule, just like NAD. Oxaloacetate is the final product of one run through the Krebs cycle and is recycled at the end. NADH+ from the citric acid cycle drops off its electrons to the first complex. Remember, oxidation is the loss of electrons and reduction is the gain. So NADH+ is oxidized as it reduces the first protein complex. The electrons that NADH+ is dropping off have a certain amount of energy, enough to cause the protein complex to pull up hydrogen ions from the stroma to the intermembrane space. While the electrons are in the protein complex, it is in its reduced form, and therefore has a specific shape that can pull the ions in. So, there is a buildup of hydrogen ions. The concentration in the intermembrane space is much higher than the concentration in the stroma. The ions want to go from high concentration to low concentration, but they can't travel through the membrane. The only opening is ATP synthase. As the hydrogen ions move through the ATP synthase, which is sort of like a turbine, energy is generated. FADH does pretty much the same thing, but its electrons are lower in energy than NADH's. So FADH dumps its electrons into the lower energy protein complex 2, and the same general processes happen. Since FADH's electrons only move through 2 protein complexes, only 4 hydrogen ions are pulled through and only 2 ATP molecules are made. Remember, the concentration of hydrogen ions is greater in the intermembrane space, so it requires energy to move additional ions against the gradient. This energy comes from the electrons. At the end of the electron transport chain is an oxygen. Remember, oxygen is an electron pig. It likes to hog the electrons. Oxygen is what pulls the electrons down the chain. It takes the movement of 2 hydrogen ions to generate enough energy to make a single ATP. So, if NADH+'s electrons move through 3 cytochromes, then 6 hydrogen ions were pulled up, resulting in 3 ATP molecules. These 2 hydrogen ions plus the 2 electrons join together with oxygen to make water. In the time it took you to watch this video, this process happened quadrillions of times. Now Specimen A will go study for his biology midterms.
It's wrong! Oh my god!
What is this? What the heck is going on here?
What didn't even...
Where is CO2H?
I hate my life.
Okay, I'm just rolling. Okay, so I need to attach it.
It is rolling. See?
Rolling on the
You
rail.
can look at it, we can see it. I'm just really, just like, yeah. Awesome.
There's a hydrogen in there.
See you. Oh my god, wait, watch it. Watch it. Oh my god, big hug. Oh, I love you.
Where is the shirt?
Dan's almost done. Waste cans.
Hang on. Listen. Is a gold tooth a flash in the pan? Is a gold tooth? Will you play your bass? Well, no, hang on, listen. No, hang on. Now? I want to know if I cross the kangaroo with a turkey, will I stuff it from the outside? I'll stuff you from the outside. Play the bass! Now listen. No, well look, if Tutankhamun
so cool.
got sick, will I call his mummy?
Go, 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 go.
Go on, play it. The
Really
convict
little
down
kids.
on bail said put me back in jail. Rang the knocker, you must be off your rocker. Let me back in his old cell. The reason he did tell.
Die, Brendan Molecule. Die, die.
Well, judge your chewing gum has more uses than it says upon the back. Can you stretch it out much further than the back on the rack? Can you lend it to your
We're in the middle of filming.
How does Coke taste now?
Tastes like-
when your lips refuse to smack.
Tastes like phosphoric acid and tooth decay. Yeah, it
There's
says.
arsenic in here.
No, it says carbonated water, high fructose corn syrup, caramel color, cancer.
Oh, I get it now.